Hello everyone, welcome to my channel Abhilash2021. If you did not subscribe to my channel till now, please subscribe it and share with your friends. In this video, we are going to discuss Essay 1 Model Paper. In section 1, we will be having 7 questions. All 7 questions are compulsory. Each question carry 1 mark. So 7 into 1, 7 marks. So let us check the 7 questions of section 1. Find HCF of 48 and 64 by ED. Sometimes in the question they will mention the full name Euclid's division algorithm, or sometimes they will mention it as Euclid's division, or sometimes as Euclid's division lemma, or sometimes as Euclid's division, or sometimes as ED only, Euclid's division. So what you need to do first is do the division of the given numbers 48 and 64. 48 ones are 48. 4 becomes 14, 6 becomes 5. 14 minus 8, 6, 5 minus 4, 1. Now this step only we need to write it as 64 equal to 48 into 1 plus remainder. Dividend equals to divisor into quotient plus remainder. Nothing but A equals to BQ plus R. Now from this step you need to pick the remainder and divisor. Again for these two numbers you need to do the division. 16 and 48. 16 3s are 48. 48 minus 48, 0. Right? This step only again. Dividend 48 equals to divisor into quotient 16 into 3 plus remainder 0. So whenever we get the 0 remainder, we need to stop the process there. After getting the 0 as the remainder, then what will be our divisor? That will become our HCF. So HCF of 48 and 64 is 16. Moving to the question number 2. Express log 512 root 2 equals to 18 in exponential form. The given question is in logarithmic form. That logarithmic form we need to convert to exponential form. Log 512 base root 2 equals to 18. Now what we need to do is log main number is 512, right? So write that as it is, equal to, here base is root 2, right? Then if you take to that side also, that base will be base only. So root 2. Here the answer is 18, right? Write that 18 as the power here. So this is how we will convert logarithmic form to exponential form. So 512 equals to root 2 whole power 18. If simplification is possible, obviously we will do that one. So 512 equals to root 2 is nothing but 2 power 1 by 2. Whole power 18 as it is. So 2 1s are 2 9s are. So the final answer is 512 equals to 2 power 9. Logarithmic to exponential. Write set builder form of the given set. A equal to 1, 8, 27, 64, 125. As soon as we see the numbers, we need to get the logic or pattern which is hidden in that numbers. 1 can be written as 1 cube. 8 can be written as 2 cube. 27 can be written as 3 cube. 64 can be written as 4 cube. 125 can be written as 5 cube. So now we can write the set A in the form of set builder as set A equals to x such that x equals to. This is always it will be there in the set builder form. So set A equals to x such that x equals to. Here observe the bases 1, 2, 3, 4, 5 is still if are there means 6, 7, 8, 9 and so on, right? So those all are changing. So that is the reason I will represent all those with some variable n. Observe the powers. For every number the power is 3 only, right? So that's why that is constant. So 3 I am keeping as it is. So x such that x equals to n cube. But what is this alphabet n then? Alphabet n belongs to, here we are starting from 1 cube. Here 1 is the base, right? So 1 is nothing but starting natural number. So n belongs to natural numbers. N less than. Then if n belongs to natural numbers means not only natural numbers are 1 to 5. 100 will come, 2000 will come, 10,000 will come, every number will come into the natural numbers again. So how many we are taking then? 1, 2, 3, 4, 5. Till 5 we are taking, right? So that's why I will write it as n less than 6. Set A equals to x such that x equals to n cube, where n belongs to natural numbers and n is less than 6. Question number 4. Write formula to find sum and product of zeros of a quadratic polynomial ax square plus bx plus c, where a is not equal to 0. So sum and product of the zeros is asking alpha plus beta equals to minus b by a, and alpha into beta equals to c by a. This is sum of the zeros and this is product of the zeros. Here a is nothing but x square coefficient, x coefficient is b and constant is c. Coming to the question number 5. If p of x is given as x square minus 16, then find the value of p of root 2. P of x equals to x square minus 16. Then we need to find out p of root 2, that is equals to, in the place of x substituting root 2 square minus 16. Here square root square cancel, then we remains with 2 minus 16. Smaller number minus bigger number, our answer will be negative. So 16 minus 2 is 14. So p of root 2 value is minus 14. A is a set of zeros of a quadratic polynomial x square minus 1. Then what is the cardinal number of A? So first of all we need to find out zeros of x square minus 1. X square minus 1, make it equals to 0. Take minus 1 to the right side. So we will get x square equals to 1. If x square is 1, then what will be the x value? Plus or minus 1. Because minus 1 square also 1 only, plus 1 square also 1 only. So set A equals to plus 1 minus 1, or else minus 1 plus 1. Then he is asking what is the cardinal number. Cardinal number is nothing but how many elements are there in the set A. That will be represented with n of A. Number of elements in set A equals to minus 1 plus 1. So only 2 elements are there. So 2. N of A is 2, or else cardinal number of set A is 2. Coming to the question number 7. X is a set of values of log 1 base 5 and log 9 base 9, and write the roster form of set X. So first let us find out the values of these given. Log 1 base 5, log 1, whatever it is the base, always the answer is 0. Next, log 9 base 9, if two numbers are the same means answer is 1. So he is asking us to write out the set X. So set X is equals to, the elements will be the answers, right? So 0 comma 1. He is asking about roster form only. So roster form is nothing but just writing the elements of it. So I wrote it as 0 comma 1. So by total 7 questions we completed section 1. Now moving to the section 2. In section 2, total 6 questions will be given. Every question carry 2 marks. So 6 2s are 12. 6 questions, 2 marks each. 6 2s are 12 marks. First question. If x square plus y square equals to 4xy, then show that 2 log of x minus y equals to log x plus log y plus log 2. First take the given equation. x square plus y square equals to 4xy. In the given question, if anywhere negative symbol is there means you subtract 2xy. If negative symbol is not at all there, then add 2xy. So here negative symbol is there, right? Then subtract 2xy. Subtracting 2xy from both the sides. Okay, so what we will get then? X square plus y square minus 2xy equals to 4xy minus 2xy. Left side I subtracted 2xy, as well as right side also I subtracted 2xy. So now if we observe this left side part clearly, x square plus y square minus 2xy is the formula of x minus y whole square, which is equals to 4xy minus 2xy. It is 2xy. Then in the question he is asking us to show that some log, right? But in this step we don't have any log, so apply logarithm on both the sides now. Applying log on both the sides. So what it will become then? Log of x minus y whole square equals to log 2xy. In the logarithm, if power is there means that power will go to the front, so write it as it is. 2 log of x minus y equals to log 2xy, nothing but 2 into x into y. In the logarithm, multiplication will become addition. So log 2xy can be written as log 2 plus log x plus log y. Hence proved. Coming to the question number 9. Kavita said that 6 and minus 4 are zeros of a quadratic polynomial x square minus 2x minus 24. Do you agree with her? So first let us take the given polynomial x square minus 2x minus 24. First we need to substitute 6 in the place of x. So 6 square minus 2 into 6 minus 24. 6 square 36 minus 2 6 are 12 minus 24. 36 minus 12 24 minus 24 equals to 0. After substituting, if we get the answer 0, then we can say that that particular substituted number is 0 of the polynomial. So 6 is 0 of the polynomial x square minus 2x minus 24. Now let us substitute minus 4 in the same equation, polynomial x square minus 2x minus 24 is the given polynomial. Now let us substitute minus 4. Minus 4 whole square minus 2 into minus 4 minus 24. Minus 4 square 16 minus 2 into minus 4 minus into minus is plus 2 4s are 8 minus 24 as it is. 16 plus 8 24 minus 24 24 minus 24 0. So here also we got the answer 0 only. So then we can say that minus 4 is 0 of the given polynomial x square minus 2x minus 24. So the question is asking that what do you agree with her? Yes, of course I will agree with the Kavita, because 6 and minus 4 are zeros of the polynomial x square minus 2x minus 24. Coming to the question number 10. Find a quadratic polynomial whose zeros are log 25 base 5 and log 27 base 3. First of all, let us simplify the given values. Log 25 base 5. Log 25 can be written as 5 square base 5. In logarithm, if the power is for the main number, it will go to the front as it is. So we will get 2 log 5 base 5. Log 5 base 5 value is 1, so 2 into 1, that is 2. 1 0, we got it as 2. Then taking the second one, log 27 base 3. Log 27 can be written as 3 power 3 base 3 as it is. 3 will come to the front, so 3 times log 3 base 3. Log 3 base 3 is 1, so 3 into 1, that is 2. Both the values we got it as 2 and 3. 1 I am taking as alpha, alpha equals to 2, and second one I am taking as beta. You can take in reverse also, anyway you get the same answer. Now we have alpha and beta values, that is nothing but zeros of a polynomial. Then we need to find out the polynomial. So when we have zeros of a polynomial, to find out a polynomial, the formula we will use is k into x square minus alpha plus beta into x plus alpha beta. K into x square minus alpha is 2 plus beta is 3 into x plus alpha is 2 and beta is 3. K into x square minus 2 plus 3 is 5x plus 2 into 3 6. Now no need to worry about what is this k, what is this cable k. So just this k is, if you have any denominator after simplification completely, I mean in the last step, to remove that denominator we will use k. Here x square minus 5x plus 6, nothing is denominator, right? So we can take the denominator as 1, right? So now to remove this 1, take the k value as 1. If k equals to 1. If multiply with 1 means nothing will change, so just we will write the polynomial as it is. X square minus 5x plus 6 is our required polynomial. Question number 11. If set M equals to PQR, then write all the possible subsets of M. It's very easy. Write the individual elements first. P. Then after Q. Individual elements first. Only one element. Then R. Individual elements completed. Then two elements together. PQ. Then QR. Then PR. Individual elements completed. Two elements completed. Then coming to the three elements together. PQR. After writing all this, then just write one empty set also. So these are total subsets of the given set. Then how do you know whether you covered every subset or not? That we will cross check with the formula. Number of subsets formula is 2 power n. 2 power n is nothing but how many elements are there in the set. Here P is one element, Q is an element, 3 is one element, so total 3 are there. So 2 power 3. 2 power 3, 2 into 2 into 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. So total 8 subsets we got. So it means every subset we wrote, we didn't miss anything at all. Coming to the question number 12. If set A equal to 1, 2, 3, 4, 5, 6 and set B equals to 4, 5, 6, 7, 8, 9, then find the value of n of A union B and n of A intersection B. Set A, set B are given, right? So first let us find out A union B. A union B means what? We need to write everything from set A as well as from set 2, right? So from set A, let us write all the elements. 1, 2, 3, 4, 5, 6. Then from set B, here 4 is there, but already we wrote 4. 5 is there, 5 is completed already. 6 is there, 6 also completed. Then the remaining are 7, 8, 9. So write those 7, 8, 9. This is set, but we want n of A union B, right? So n of A union B, nothing but number of elements in A union B. So in A union B, how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9 elements are there. So n of A union B value is 9. Then he is asking about n of A intersection B, right? So first let us find out A intersection B set. In intersection, we will write all the elements which are common in both. So here 4 is there, here also 4 is there, here 5 is there, here 5 is there, here 6 is there, here also 6 is there. So A intersection B will be 4, 5, 6. Then he is asking here also same to find out n of A intersection B. Then n of A intersection B equals to number of elements in A intersection B. 1, 2, 3, 4, 5, 6. So 3 elements are there total. N of A union B is 9 and n of A intersection B is 3. Moving to the question number 13. A and B are two non-empty sets. Draw Venn diagram which represents A is subset of B. A is subset of B, we can write like this also, that is A is smaller than B. This is just for understanding purpose only, so please don't use this in example. A is a subset of B, that is nothing but A is smaller than B. So smaller circle is A, bigger circle is B, that's it. Set A is smaller than set B, nothing but A is subset of B. So by this we completed section 2 also. Now coming to the section 3. In section 3 total 4 questions will be there. For every question one choice will be there. And each question carries 4 marks. 4 times 4 equals to 16 marks. In 14, 2 questions. Any one we need to write. In 15, 2 questions. Any one we need to write. In 16, 2 questions. Any one we need to write. And 17 also 2 questions. Any one we need to write. So for every question there is an internal choice. Let us check then how to solve this. First question. Prove that root 3 plus 2 root 5 is an irrational number. Whenever it is asking this kind of question, so their sentences will be there in the starting of a question itself. So that sentences are compulsory. On the contrary, let us assume root 3 plus 2 root 5 is rational. So root 3 plus 2 root 5 can be written in the form of P by Q, because I said that those two are I'm assuming those two are rational numbers, right? So if it is a rational number, then definitely it can be written as in the form of P by Q. But according to the textbook, instead of writing P by Q, they are writing A by B. So I am also writing it as A by B. The conditions, everything are same. A comma B belongs to integers and B not equals to 0. You can write one more condition, that is A comma B co-primes, nothing will happen. Now, root 3 is an irrational number, 2 root 5 is also an irrational number. So both are irrational numbers, then we cannot simplify anything. So that is the reason we will do squaring on both the sides. Squaring on both the sides. So that will become root 3 plus 2 root 5 whole square equals to A by B whole square. Now here root 3 plus 2 root 5 whole square is in the form of A plus B whole square. So here A is root 3 and B is 2 root 5. So if we expand it, we will get A square plus B square plus 2 into A into B. That is equals to A by B whole square, A square by B square. Square root square cancels, so remains with 3 plus. Here don't do this mistake. Root and square root here won't be get cancelled, because here some other number 2 also there. So then what you need to do is separate it. 2 root 5 whole square, right? So this square is applicable for number as well as for this also. So that will become 2 square into root 5 square plus 2 2s are 4 into root 3 into root 5. 3 5s are 15 equals to A square by B square. Now this square root and square cancel. 3 plus 2 square is 4 into 5 plus 4 root 15 equals to A square by B square. 3 plus 4 5 is 20 plus 4 root 15 equals to A square by B square. 3 plus 20, 23 plus 4 root 15 equals to A square by B square. Take 23 to the right side. 4 times root 15 equals to A square by B square plus 23 will become minus 23. Write this 23 as 23 by 1. Let us do cross multiplication here. Left side part as it is, 4 root 15 equals to A square into 1 A square minus 23B divided by B square into 1 B square. Now from the left side bring 4 also to the right side. So we will get root 15 equals to a square minus 23 divided by 4b square. In the beginning of the answer only we took a comma b both belongs to integers. So here right side we have a, b square, 23 and 4. These all are integers only. So as a comma b comma 23 comma 4 are integers, RHS is rational, but here LHS is root 15, right? So root 15 is irrational. This contradiction has arisen due to our wrong assumption. So the given question is an irrational number. Now in that 14th one only, this is second, choice, either the first one or second one, any one we can write it. So the second B question I can say, show that the square of any positive integer is of the form of 4n or 4n plus 1, where n belongs to integers by using Euclid's division. Let a be any positive integer. This is the first statement we need to write for everything. And b equals to, that will be given the question only, 4n plus 1, that number 4 is b. If b value is 4, then what will be the reminders? Always the remainder will be less than or equals, less than the divisor. So 0, 1, 2, 3. Now these we need to substitute in our Euclid's division formula, that is a equals to bq plus r. A equals to b value is 4q plus 1 by 1 remainder we will substitute. And in the question he is speaking completely about square, right? So first I am substituting 0 remainder. A equals to 4q plus 1, 4q. He is speaking about square, right? So I am doing squaring on both sides. So I will get a square equals to 4q whole square. A square equals to 4q whole square is 16q square. If you observe the question, is saying clearly it should be in the form of 4n plus 1. In both the number 4 is there, right? So that is the reason from 16q square I am taking 4 common. So we remains with 4q square. Now this is in the form of 4n. Next, same formula, a equals to bq plus r. A equals to b is 4q plus r is second remainder 1. Again squaring on both the sides. A square equals to 4q plus 1 whole square. A square as it is. So 4q plus 1 whole square, again it is in the form of a plus b whole square. If we expand, a square plus b square plus 2 into a into b. 4q whole square, 16q square plus 1 square, 1, 2 4s are 8q. Now from this also we need to take 4 common again. From 16 I can take 4 common, from 8 also I can take out 4 common. For 1 we cannot take 4 common, so I am writing it as 16q square plus 8q. 1 completely separately I am writing now. From these two let us take out 4 common, then we remains with 4q square plus 2q plus 1 as it is. Now it is in the form of 4n plus 1. 0 remainder completed, 1 remainder completed, then remainder 2. A equals to 4q plus 2. Squaring on both the sides. A square equals to 4q plus 2 whole square. 4q plus 2 whole square is in the form of a plus b whole square. So if we expand, a square plus b square plus 2 into a into b. 4q whole square, 16q square, 2 square 4, 2 4s are 8, 8 2s are 16. 16 and 4 both will come in 4 tables, so I simply will take out 4 common. Then remains with 4q square plus 1 plus 4q. This is in the form of 8n. Now you try for 4q plus 3 as the remainder. Coming to the next question number 15. In this 15 also a and b both will be there, any one we need to write. If 5.2 whole power x equals to 0.52 whole power y equals to 100, then find the value of 1 by x minus 1 by y. So the given equation is 5.2 whole power x equals to 0.52 whole power y equals to 100. It means 5.2 whole power x is equals to 100 as well as 0.42 whole power y also equal to 100 only. So let us separate both. We can write it as 5.2 whole power x is equals to 100 as well as 0.52 whole power y equals to 100. 5.2 whole power x equals to 100 can be written as 10 square. Here also same 0.52 whole power y equals to 100 can be written as 10 square. Now what I will do is, there is a relation between 5.2 and 0.52. So I will try to make one equation only with this 5.2 and 0.52. So for that I need to remove this power x left side and here power y left side, right? So to remove those powers, what I will do is, to the left side part, both the powers I will divide by x. That's it. So that x will get cancelled. Then I will remains with 5.2 equals to 10 power 2 by x. Here also, to remove that power, both the sides, power I will divide by y. So y will get cancelled. Then we remains with 0.52 equals to 10 power 2 by y. Now if we observe this left side part 5.2 and 0.52, what is the relation between these two? The relation is 0.52. If you multiply with 10, you will get 5.2. So 0.52 value is 10 power 2 by y into 10 as it is equals to 5.2 value is 10 power 2 by x. This 10 can be written as 10 power 1. 10 power 2 by y into 10 power 1. Both the bases are same, so we can add the powers. So that will become 10 power 2 by y plus 1 equals to 10 power 2 by x. Both the bases are equal, so powers also equal. 2 by y plus 1 equals to 2 by x. Take 2 by y to the right side. 1 equals to 2 by x plus 2 by y will become minus 2 by y. 1 equals to 2 by x, 2 by y. From these two we can take out 2 common. So remains with 1 by x minus 1 by y. Take 2 also to the left side. Then we get 1 by 2 equals to 1 by x minus 1 by y. He is asking about the value of 1 by x minus 1 by y. So 1 by x minus 1 by y value is 1 by 2. Coming to the choice question in this, set A equals to x such that x belongs to integers minus 4 less than or equals to x less than or equals to 3, and set B equals to x such that x is a whole number x less than 6. Then find A minus B and A intersection B. It's a very small question actually. So set A, if we speak about x such that x belongs to integers and minus 4 less than or equals to x less than or equals to 3. Here less than or equal to is there, so we need to include minus 4 also. Here less than or equals to is there, so we need to include plus 3 also, right? So let us write all the numbers which are in between those two now. Minus 4, then after minus 3, then after minus 2, then minus 1, 0, 1, 2, 3. Less than or equal to symbols are there, that is the reason we are including minus 4 and plus 3 also in the set A. Now coming to the set B. X such that x is a whole number x less than 6. So very easy then. Whole number start from 0 onwards. 0, 1, 2, 3, 4, 5. He is speaking x less than 6. So we should not include 6. So I got set A and set B. Then he is asking us to find out A minus B and A intersection B. So let us do it. First, A minus B value we need to find out. How we are going to find out minus or difference of any sets? From the set A, remove all the elements which are there in B. Here 0 is there, in set B also 0 is there. Here 1 is there, in set B also 1 is there. Here 2 is there, set B also 2 is there. Here set 3 is there, set 3. Those all you remove. Now touch only set A. From set A, which are the remaining elements, you write all those. Minus 4, minus 3, minus 2, minus 1. That's it. This is a minus b value. Then coming to a intersection b. Intersection is nothing but the elements which are common in both. Now whichever I crossed out, those are the elements which are common. So 0, 1, 2, 3. This is a minus b and a intersection b. Coming to the question number 16. If 1 is a 0 of cubic polynomial, p of x equals to x cube plus 2x square minus x minus 2. Find the other two zeros. So here he said that plus 1 is a 0. Then the factor will be x minus 1. Plus 1 is there means minus 1. Minus 1 is there means plus 1. Just change the symbol. Then this will become a factor. With this factor, you need to divide this p of x. So let us do the long division. X minus 1 is the divisor and x cube plus 2x square minus x minus 2 is the dividend. Then we will get one quotient. X should be multiplied by what? We will get x cube, that is x square. Minus 1 into x square also we need to do. So x into x square is x cube. X cube. Minus 1 into x square minus 1x square or simply x square. Plus become minus, minus become plus, these two cancel. 2x square plus x square, 3x square, drop minus x minus 2. If you drop 1 also, no problem. X should be multiplied by what? We will get 3x square. X into 3x. X into 3x is 3x square. Minus 1 into 3x is minus 3x. Changing the symbol again. Plus become minus, minus become plus. These two cancel. 3x minus x, 2x minus 2. X should be multiplied by what? We will get 2x. X into 2 is 2x. So x into 2 is 2x. Minus 1 into 2 is minus 2. Plus become minus, minus become plus. Plus 2x minus 2x cancel. Minus 2 plus 2 cancel. Then we remains with answer 0. After getting the 0, take this quotient, that is x square plus 3x plus 2. X square plus 3x plus 2. Split the middle term into two terms. X square as it is. 3x I am writing it as 2x plus 1x plus 2 as it is. From x square plus 2x we can take out x common, then remains with x plus 2. And from x plus 2 we can take out 1 common, then remains with x plus 2. Always make sure that here and here the bracket should be same compulsory inside. So that is same, right? So write it once, x plus 2 into here extra x, here plus 1. So x plus 1. Here x plus 2 is there, so x value will be minus 2. Here x plus 1 is there, so x value will be minus 1. So the other two zeros are minus 2 and minus 1. In this choice question now. Alpha comma beta are the zeros of x square plus 3x minus 10. Then find the value of 1 by alpha square plus 1 by beta square. For this, two methods will be there. The first method is by finding the alpha and beta value by splitting this into two terms and finding the x value and substituting that in the place of alpha beta. Otherwise, solving this only directly. So first let us go with this, splitting the middle term. X square plus 3x minus 10. X square as it is, 3x I am writing it as 5x minus 2x minus 10 as it is. From the first and second terms we can take out x common, then remains with x plus 5. From the third and fourth terms we can take out minus 2 common, then remains with x plus 5. So x plus 5 into x minus 2. Here x plus 5 is there, so x value will be minus 5. X minus 2 will be there, so x value will be plus 2. Now one we will take it as alpha and another we will take it as beta. Now let us substitute there 1 by alpha square plus 1 by beta square. 1 by alpha is minus 5 square plus 1 by beta is 2 square. That is equals to 1 by 5 square 25 plus 1 by 2 square 4. Both the denominators are different, so we need to do with the cross multiplication, right? 1 into 4, 4 plus 25, 1s are 25 divided by 25, 4s are 100. 4 plus 25, 29 divided by 100. Coming to the 17th question. This is the last question in this paper. 17th also A and B will be there. First question. Find zeros of x square plus 2x minus 3 by graphical method. So in this I am not at all going to explain anything related to graph. That graph related already I uploaded one video in the channel. So please check that. The link I will keep it in the description box. So now just calculation part only we will do. X square plus 2x minus 3 is a quadratic polynomial. So how many more numbers you will substitute, that much accurate figure you will get. X, y, x comma y. Okay, these are the numbers which I am going to substitute one by one in the given question. 0, 1, 2, 3, then minus 1, minus 2, minus 3. First, the question is x square plus 2x minus 3. X square plus 2x minus 3. Okay, right. Now first I am substituting 0. 0 square plus 2 into 0 minus 3. 0 power anything is 0, 0 into anything is 0 minus 3. So zeros if I remove, I will remain with minus 3. So when I substituted 0, I got the answer minus 3. Next, plus 1 I am substituting. 1 square plus 2 into 1 minus 3. 1 square is 1 plus 2 ones are 2 minus 3. 1 plus 2, 3, 3 minus 3, 0. So when I substituted 1, I got 0 here. Then I am substituting 2. So what will get then? 2 square plus 2 into 2 minus 3. 2 square 4 plus 2 2s are 4 minus 3. 4 plus 4, 8 minus 3, that is 5. So when we substituted 2, we got 5. Then substituting 3. 3 square plus 2 into 3 minus 3. 3 3s are 9 plus 2 3s are 6 minus 3. 9 plus 6, 15 minus 3, that is 12. So when I substituted 3, I got the answer as 12. Then substituting negative numbers now. First I am going to substitute minus 1. Minus 1 whole square plus 2 into minus 1 minus 3. Minus 1 whole square plus 1 plus into minus minus 2 ones are 2 minus 3. 1 minus 2 minus 3 minus 5. 1 minus 5 minus 4. So here minus 4. Then substituting minus 2. Minus 2 whole square plus 2 into minus 2 minus 3. Minus 2 whole square 4 plus into minus minus 2 2s are 4 minus 3. Plus 4 minus 4 cancel, then remains with minus 3. Write that minus 3 here. Then substituting minus 3. Minus 3 square plus 2 into minus 3 minus 3. Minus 3 square 9 plus into minus minus 2 3s are 6 minus 3. 9 minus 6, 3, 3 minus 3, 0. So I got here 0. Then if you write the last point, this will be minus 3 comma 0. This is minus 2 comma minus 3. This is minus 1 comma minus 4. 0 comma minus 3. 1 comma 0. 2 comma 5. 3 comma 12. These points if you represent on the graph, you will get the figure. Coming to the choice question in this. Set A equals to x such that x is a factor of 24. So set A. X such that x is a factor of 24. 24 will come in which tables? 1 table, 2 table, 3 table, 4 table, 6 table, 8 table, 12 table, 24 table. Then set B. x such that x is a composite number less than 15. 1 is not a composite number, 2 is not a composite, 3 is not a composite, then 4, then 5 is not, 6, 7, 8, then 9, then 10, then 12, then 14, because he said less than 15. So 15 won't be included. Now he is asking to find out A union B as well as intersection B through the Venn diagram. It's very easy. First let us do union, then after intersection. Draw one rectangle, then two circles. One is for A and one is for B. On the top right corner, keep the mu symbol, that is universal set. In set A and B, which are common, first select those. 4 is common, 6 is common, 12 is common. Write all those common elements in this middle part, that is 4, 6, 12. Now, after selecting the common, what are remaining from A? 1, 2, 3, 8, 24. Write it here. 1, 2, 3, 8, 24. Then from B, remaining are 8, 9, 10, 14. Write those here. 8, 9, 10, 14. Now he is asking about union, right? So two circles completely you need to shade. Two circles completely you need to shade. That's it. This is A union B. Coming to the A intersection B. Same figure, everything same. Rectangle box, two circles, one for A and one for B. This is universal. The common elements, you write it in the middle, that is 4, 6, 12. 4, 6, 12. And 1, 2, 3, 8, 24. 1, 2, 3, 8, 24. Then 8, 9, 10, 14. 8, 9, 10, 14. Now he is asking or speaking about the intersection, right? Intersection is nothing but common. So only the common part you need to shade. That's it. This is A union B as well as A intersection B.